Well, hello there, amazing people. I'm super excited to be here with you on yet again another video in this series where we're learning how to balance chemical equations. And up next, we're talking about the parts of a chemical equation. What are the things that make up this interesting phenomenon called the chemical equation? Well, we're going to be finding out in this video, so I would like you to sit tight, relax, and enjoy every bit of what I've got coming for you. So before you can balance a chemical equation, the first thing you must do is you must understand the language that are used in them. There are certain terminologies that are used when you're balancing a chemical equation, and you must familiarize yourself with them in order to be able to find your way around the concept of balancing chemical equations. Alright, so let's check out what some of them are and understand what they mean. So in this lesson, we'll break down the parts of an equation. We'll be seeing what symbols mean, what formulas mean, coefficients, subscripts, the plus signs, and the arrows. These are some parts of a chemical equation that you must be familiar with. So we start with the first one, a symbol. A symbol is the short form used to represent elements. So instead of writing the full name of an element, a chemist uses a symbol instead, especially when balancing chemical equations. Now, those symbols are denoted using letters. For example, instead of writing hydrogen when balancing a chemical equation, a chemist simply uses the symbol H. Instead of writing oxygen in full, we use the symbol O. Instead of writing magnesium, we use the symbol Mg. And instead of writing sodium, we use the symbol Na. These symbols come from the periodic table. That is where they are derived from. Some symbols use one letter. We saw the example of hydrogen and oxygen. And some symbols use two letters. We saw this example of magnesium and sodium. So that's what a symbol is. Next up is a formula. What is a formula? A formula is simply the part of a chemical equation that shows the elements that are present in a substance and how many atoms are there. So here are two good examples of what a formula is. We have H2O. This is the formula for water. It is the formula for water because it tells us that the elements that are contained in water are hydrogen and oxygen. Not just identifying the elements, it also tells us the number of atoms of each element that are present. For hydrogen, we have two atoms because this subscript of 2 belongs to hydrogen. And for oxygen, we have one atom. So the formula for water tells us that water contains two atoms of hydrogen and one atom of oxygen. Basically, this is what a chemical formula tells us. Next up, we have carbon dioxide, CO2. This is telling us that carbon dioxide contains carbon, that's the name of the first element denoted by the C, and oxygen. Now, it's not just telling us the kind of elements that are present, it's telling us the number of atoms that are present. We have one atom of carbon and two atoms of oxygen. That's what it tells us. So that's what a formula is. Next up is a coefficient. What exactly is a coefficient? A coefficient is a big number written in front of substances. Okay, now the coefficient simply tells us the number of molecules that are present. So for example, we have H2O. You can see a capital or a big number 2 written in front of the H2O. Now that big number 2 is called the coefficient. It is telling us the number of molecules that are present, 2H2O. So it's telling us that this entire H2O molecules, we have 2 units of it present. 2 units of it present. So you can see what a coefficient actually means. Now a coefficient also changes the total number of atoms because it multiplies everything that comes after it. So in the example that we looked at, 2H2O, these 2, which is the coefficient, affects everything that stands behind it. So it affects this hydrogen and it also affects this oxygen. So if I were to ask you how many atoms of hydrogen are contained, I would simply say these 2 over here multiplied by the coefficient, which is 2. That gives us 4 atoms of hydrogen. And if I said how many atoms of oxygen are present, I would simply use these 2 to multiply oxygen, which is 2 atoms of oxygen that are present. I hope you see how the coefficient actually works. So that's what the coefficient does in a chemical equation. So 2H2O has 4 hydrogen atoms and 2 oxygen atoms. Basically, the coefficient multiplies everything that comes after it. That's what the coefficient does. So fourthly, we have the subscript. Now the subscript is the small part of a chemical equation. They are the small numbers that are written below chemical symbols. So we saw the example of H2O, which is the formula for water. You can see a small number 2 written below and in front of hydrogen. What does that 2 tell us? It tells us how many atoms of the element that it is attached to are present. So this 2 is attached to hydrogen. It tells us that there are 2 atoms of hydrogen that are present. Now here's one mistake that students make a whole lot of times. They confuse coefficients and subscripts. No, 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 no. That's not the way to go. In balancing chemical equation, that is absolutely not allowed. So for instance, you can see these 2 examples over here. They are not the same thing, even though there is a number 2 in front of the first one and there are number 2's contained in the second one. They are not the same thing because over here oxygen has just 1 atom and there are 2 atoms of oxygen. So when balancing chemical equations, you are not allowed to change the subscripts. No, you're only allowed to change the coefficients. So coefficients change the amount of the substance that is present. Subscripts change the substance itself. So here's an example. We have H2O. If I change the coefficient and I say 3H2O, it means I now have 3 molecules of water present. If I say I want 4 molecules of water, I would simply cancel out these 3 and write a 4 instead. Now I have 4 molecules of water present. But if I change these 2 and I change it to 3, it means I have changed the entire substance. And that's not the way to balance a chemical equation because new atoms are not created nor destroyed in the process of balancing a chemical equation. And then we have the penultimate one, which is the plus signs. The plus sign simply means reacts with or and. So if we are reacting hydrogen and oxygen, this plus sign simply can be read as and. So if we're to read this in English, it means hydrogen and oxygen. The substances are reacting together, basically. That's what it means. And then finally, we have the arrow. The arrow in a chemical equation simply means produces or changes into. So if we're to read this chemical equation in full, it means hydrogen and oxygen produces water. Hydrogen and oxygen produces water. Hydrogen reacts with oxygen to produce water. So that arrow separates the reactants from the products. The reactants on the left hand side and the product on the right hand side. So let's analyze this equation completely. You can see the equation on the screen right now. If we're to identify the parts of a chemical equation, we start with the symbols. The symbols that are contained, we have magnesium and we have oxygen, Mg and O. That's the symbol part of the chemical equation. How about the coefficients? You can see a coefficient over here, big number 2 right in front of magnesium, and you can see a big coefficient right in front of magnesium oxide on the right hand side of the chemical equation. So we have identified two parts of the chemical equation. How about the subscripts? Are there any subscripts contained? Yes, we have a subscript right in front of oxygen, telling us that oxygen contains two atoms present. And then the plus sign simply means that oxygen and magnesium are reacting together. Magnesium reacts with oxygen, and then the arrow simply means produces. So if I were to read this chemical equation in English, I have 2 Mg plus O2 giving me 2 MgO. I would simply say 2 molecules of magnesium, because you can see there are 2 molecules of magnesium contained as denoted by the coefficient 2. 2 molecules of magnesium reacts with 2 atoms of oxygen, because you can see oxygen has 2 atoms present, to produce 2 molecules of magnesium oxide. 2 molecules of magnesium oxide. I hope you can see how this works. 2 molecules of magnesium, can see 2 molecules of magnesium reacting with 2 atoms of oxygen to produce 2 molecules of magnesium oxide. Easy peasy and straight to the point. So here's a quick practice question I'd like you to handle before we get to the next video. The chemical equation is on the screen right now. I want you to identify the coefficient, the subscript, the reactants, and the product. Here is the chemical equation. Do that. Drop your answers in the comment section and I'll be there to give a reply to that. So up next we have the video that talks about some of the mistakes that students make when they balance chemical equations. I can't wait to see you in there. I look forward to doing that with you, and up until then, stay blessed.